Day year 10s, I hope you're well. We're going to have like two parts to this, okay? First, we're going to look at the formation of the Bahamas. So if you could freeze this and you can copy down this unit, topic, and date and objective, okay? So we're looking at the formation of the Bahamas. And if you go to page 7, you'll be able to see this development, okay? So if I'm just going to change this to page 7 here, okay? And on this page, we can see the Bahamas here, but then the darker blue areas are where the sea is deepest, and then we've got where it's the shallow waters is a lighter color. And as we can see, the islands are kind of just inside, just by the edges of these shallow water pieces there. But then when we go from that, if you actually look, so these islands that are on here all sit on the platforms, okay? Sit on the platforms, so it can just, so down below the sea, and then the land comes over the ocean, and that's how we can see it, and that's how people live on them, okay? And we're going to find out about how these bits of land are formed, okay? Now, if we look on this here, this one actually shows some of these platforms that we sit on, okay? The islands kind of sit on these platforms, and these are connected by the same little shelf here. So Andros, and you can see Nassau here, and Eleuthera are all connected in that same shelf there. Then we've got the separate one up here. And many of these kind of islands are kind of all formed in the same way. When I say that, is in its geological manner, okay? So how it's in its geology. And if you go to page 9, and I'll let you read through this, and I'm just going to briefly talk about what comes up on this page 9 here, when it talks about the formation of the platform. And as I said, it's kind of related to its neighbors. So for example, in southern Florida here, it's actually kind of like a large-scale version of Andros here, okay? And we go from there. Now, what I want you to do now is actually go to page 42, and we're going to find out how these were formed. So if you go here, and it kind of all links to this idea about ice ages, okay? Now, this table at the top kind of goes through from this current ice age, which goes all the way to the present, these periods of glacial and interglacial. Glacial is going to be when it's colder, and interglacial are these kind of warmer periods, okay? And during the glacial period, now in the Bahamas, the weather's not going to change that much. And this describes all of this here. So I'd go through and highlight this. I'm going to describe it again briefly by myself. So during the glaciation periods, in the northern latitudes, so near the poles, it's going to be an incredibly bad winter, okay, that continues and continues. And when that happens, so as it says here, like a bad winter that never ended, as that happens, more water becomes frozen in the sea, and this creates a change in sea levels. So in the Bahamas, it might have been a little bit cooler, but generally there's going to be a massive change to the sea levels. Now, as it says here, so the Bahamas fell by well over 120 meters, the sea levels fell, okay? And as this happened, okay, so we've got this platform, and we can actually, you can start to be able to see it, so it comes above the sea. And we're going to look at how, as this happened, what forms and what changes happen. And these are these oolitic ridges. Now, you would have remembered this word oolitic from when we did about limestone, and we'll go over this in a little bit more detail in a second. Okay, and these oolitic ridges, now these diagrams on this page really kind of show it pretty well. So before the ice age, you've got these little oolite banks, got the reef here, okay, and the sea is above, so you can't be seen at the moment, okay? Then what happens is that we go through into the falling sea level, and it starts to come across. Now the prevailing wind comes across, so the most common wind, and it starts to bring across any loose material, okay, any loose material and is blown over here, and it kind of gets caught up here and just deposited here. Now, the most common material to be moved was these oolites, okay? So really fine, light materials that was blown across, and then they kind of gathered over here, okay? So at the beach, we got these kind of sand dunes that developed here, okay? And as we go through during glaciation, a whole load of land is exposed, okay? And then this part here, so all these like sand dunes become cemented, and it becomes limestone, okay? And we'll talk about these different processes. It's just kind of a brief overview at the start, okay? Then we got from here, then the interglacial starts, so the sea levels start to rise again. The coral, so we have new coral growth because it's under the water, and we've got from there, and so we still have these parts that are above the water here, okay? And then later, these oolites are still blown across from this reef here, and we create these new dunes, and we've got a new beach here, and this process starts again, okay? And so this process happens over and over again, and this is how that land is created, okay? And it talks about at the bottom here why the oolites were the materials that blew across. So I go through those 2 pages, just underline the main points. I've tried to explain it quickly, and we go from there. Now, if you jump now to page 49, now we've got these. How do we know that there's been sea level change? Okay, now there are different ways of knowing from it. One is going to be like these kind of fossil corals. Okay, so you can see the corals that. So we've got like a small patch of coral reef that is about 5 to 6 meters above sea level, which we can find in New Providence, which shows that maybe at one point that was under the that used to be under the sea. Okay, now there are other things to consider. So there's going to be land subsidence, so that things be changed from there. So it's not going to be exactly 5 to 6 meters, but we can just conclude from there. Another example is like in Cockburn Town in San Salvador, which is about 5 to 6 meters above. Okay, now what we're going to look at now is if you jump across, because we're just really looking about why, like how has the land been formed. So it becomes that sediment gets blown across, as we saw in those diagrams, but then but how do we get the sediments to the rocks? Okay, how do we get from the sediments to the rocks? So in geology, this is known as diagenesis, and you can go from there. So this is where the grains become cemented together. Now, in the Bahamas, this process happens so quickly, okay, that actually a rock could be formed in less than 100 years. So there's actually been examples of like fossils of glass from cola bottles, and now cola bottles have obviously not been around that long, so we know that generally what the time frame when this was from and how this has happened. Now there are 2 processes where this sediment becomes into a rock. We've got cementation, okay, and this is the collection around the skin of fine crystals. Okay, so it goes from here. This diagram here describes that example, and then we've got recrystallization. Okay, this is where grains of sediment change their crystal type. In the most common is aragonite to calcite. Okay, and aragonite is that, and you're going to hear this quite a lot, is this calcium carbonate. Okay, that comes up a lot in the processes. Now, if you now go to chapter 2, so if we just go to the front of the book, you look at chapter 2, so we've got 14, page 14. Okay, and this kind of just goes through about how these sediments have kind of formed or where they've come from, okay, and how they're produced. Now, if you think about everything that we find and then we live on now, so all the surface, the land, this is from deposited material, okay? And they can be created by three ways, okay? So we've got chemical, and it goes into more detail on the next page about cryptocrystalline grains and how that happens. We've got biologically, so from skeletal remains, okay, and that's spoken about at the bottom here. And then we've got physically, okay, by the erosion of the coast and the coral reefs, okay, and it breaks down the rock, and we go from there. But overall, this sediment is converted to rock by lithification, okay, easy for you to say, and go from there. Now, in the Bahamas, as we said, this is all from, we've got this idea, why is it that we know that land is from this deposited materials? Well, I think it mentions it to the bottom here. So there's no volcanic material, okay? So no igneous rock, no metamorphic, only really limestones and their relatives, so based on that. And most of the land is oolithic. Now, I think this book goes into detail. It talks about when they've drilled into the ground, okay? I'll come back to that in a second. But they've drilled into the ground and they've seen that most of the ground is made of this oolithic limestone, okay? And we've got this when we got about the oolithic limestone. So let's go in a bit more detail about that. So if we go to page, let me get to it. Oolithic sediment, sediment, sorry, not sentiment. Page 22, okay? And this just goes through what is oolithic sediment and why is it so common in the Bahamas, okay? And the oceanic water moves onto the Bahamas bank, okay, and this is just where we go, it's warmed and it kind of precipitates the sediment called oolite, okay? And this is seen as these fine sand and fine white sand, calcium carbonate. Now in the Bahamas, it's very shallow sea, and the oolites need shallow sea to form. Also, any small changes in temperature, increase in temperature, is going to create more oolites. So when the tide comes in, this increases the temperature by about 3 degrees centigrade, okay? So as the tide comes in, there's actually going to be that, and that's going to lead to that sediment being deposited, okay? And that oolite. And it comes from there. So generally, it really all comes back to this. I think this first picture kind of shows it. So if I go on page 7, we can kind of see all of these. So based on the seed there, and then the platform, and then when we looked at page 42, if I was going to overall, this process is here. So these diagrams here kind of show how the land has built up over time, and we've created the land that we live on today, okay? Now, I know I've spoken a lot there, and all I want you to do is go through those notes on there. Now, I've left some notes on the PowerPoint, okay? So you can take some notes from there, and you can go through the textbook to make sure you've got those notes. Next lesson, we're going to be talking about ridgelands, okay? And that is what we'll move on to next, okay? If you have any questions about that, and if I was you, I'd just listen through to that video a few times and just make some notes there, okay? If you have any questions, then please send me an email. Thank you.